Okay, so this lesson is about isobars and isotherms. So we're talking about how are we going to make visible patterns from temperature and pressure data. Alright, so right now in your notebook you should make sure to copy the title, the date, today's aim, and answer the 3 questions of the warm-up, the 4 types of the fronts, what kind of air is behind a cold front, and what kind of air is in front of a warm front. Alright. Welcome back. The lesson overview. Today's lesson we're going to learn about isobars and isotherms, and we're also going to explain how isobars can indicate wind speed. So let's get to it. We're going to start out with some vocab. We use isolines to show places that have the same value on a map. So into your notes, please copy down isoline, a line on the map that connects points of equal value. Another way of saying this is that everything on the line is equal to the number that the line says. There are 2 specific types of isolines that we need to know for the regions and for our milestone in this class, and they are isotherms. Isotherm meaning having to do with heat, and so an isotherm connects lines of equal temperature, and isobars, bar referring to barometric, isobars connect lines of equal barometric pressure. So let's see what these look like. After you've copied this down, just pause it, copy them down, and let's take a look. So here's what an isotherm map looks like, right? So you can recognize this outline. This is the United States. New York City is right where I've got my cursor right now, right here. Okay, and so every line on this map represents a specific temperature. And what you can see is that, like, this line is the 80 line. So it drops here and it comes up over there. And so that means that every single spot on that line is equal to 80. And the next line is 75. So what we figured out now is the interval, so the number in between is 5, right? Each line is going up or down by 5. So we start in here at 45, then 50, then 55, then 60, then 65, then 70, 75, 80, all the way up to a 90 isotherm. Okay, so it's important for us to know also that anything in between the lines we have to estimate. So I asked down at the bottom, what could be a possible temperature for New York City? What do you think? All right, we have a 65 isotherm here, and the 70 isotherm there, and New York City is in between those two. So if you give an answer that's anywhere between 65 and 70, so 66, 67, 68, and 69, you would be right. You cannot say 65 or 70 because you are not on the line. So do not give an answer of numbers on the line. This is an isotherm, so we're talking about temperature. An isobar, whoa, my computer went crazy. Sorry about that. So we're back. Isobars are lines on a map that represent equal pressure. So they work the same as an isotherm. This is a very simple map for us to read, right? We see this line here represents the 1008 millibar pressure line, and you can see it kind of goes off the map, and then it would come back on over here. This is the 1004 isobar. This is the 1000 isobar, and this is the 996. And so in the middle here is the low pressure system. So once again, let's ask the question here at the bottom. Think about this. What could be a possible air pressure for New York City? So here's New York. Notice it's between a 1008 and a 1004 line. So what could a possible pressure be? If you gave an answer of 1005, 1006, or 1007, you would be correct. It can't be 1004 because we're not on that line, and it can't be 1008 because we're not on that line. New York's pressure is somewhere in between those two, right? And each line you'll see is going up by an interval of 4. 996 plus 4 is 1000, 1000 plus 4 is 1004, etc., etc. So if you were going to draw another line out, the next line would be 1012. So why do we use these lines? Well, because they make visible patterns out of data, right? If you just had a map with lots of numbers written, it'd be really kind of hard to read, and this is supposed to make it a little bit easier for us to read. And the biggest thing that it tells us about especially isobars, is it tells us about where wind speed is fast. So remember, wind is caused when air moves from areas of high pressure into areas of low pressure. Things want to flow from high to low. Rhymes. It can't get easier to remember. That's what causes wind. So looking at this map, here we have the center of isotherms, a low pressure, right? So the air is going to flow to it. And I want to know, where will the wind flow the fastest? Now this seems like it's kind of impossible to answer, but actually it's not. The way you know where the wind is the fastest is where the lines, the isobars in this case, are closest together. Okay? So right up here, this is where you have high pressure very close to low pressure. Here you have 1028 pressure, and here you have a line of 1004 pressure. And so because that's so close together, the air in this high pressure just wants to rush down in to fill in this low pressure area. So remember, the wind flows fastest where the isobars are closest together. And therefore, the opposite is also true. Where would the wind speed be the slowest? Well, where you have the widest space between the isobars. Okay? So the last new piece of information is how air moves around high and low pressures. Wind around high pressure system moves clockwise, like a clock does, and outward, right? The outward piece makes a lot of sense because wind wants to flow from high to low. So wherever it's highest, it's going to get away from that pressure, and it's going to move out in a clockwise motion. And then low pressure wind moves around a low pressure system counterclockwise, so the opposite direction that a clock's hands move, and they move inward, right? That makes sense because things flow from high to low. So the wind wants to flow into the low pressure. An easy way to remember the movement and clockwise versus counterclockwise is to think about a room. High pressure moves clockwise, high clock, like a clock is in a room, the clock is high up. Low pressure moves counterclockwise, like a counter is in a room. So high pressure, high clock, low counter. And things flow from high to low. Let's see this in action. Here is an awesome website showing the winds on Earth right now. So New York City is right about here, and you can see north and east of us there's this massive amount of wind. Look how fast these winds are whipping through. So this would be the location of the low pressure, right? How do we know it's low? Well, for one thing, the wind is flowing into it, so things flow too low. And also we can see the motion is a counterclockwise direction. So winds are flowing counterclockwise and inward, and this is where the super low pressure would be. Can we locate any high pressure systems? I think right here there must be some high pressure, right? Because we see clockwise movement coming out, and we don't see any winds coming in. In fact, we just see winds all moving out. So there's got to be some high pressure here. I think this is another good location for high pressure. See, winds are moving out of it. Right, can we find any other low pressure systems? Let's see if we can find another low. I'm going to move the map up there. Whoop. Yeah, so look at this crazy thing. This is some kind of really insane pressure system. I'm not even positive. Yeah, that's definitely a low pressure because look how the wind's rushing in and it's moving around in a counterclockwise position. Alright. Here's another one over here, over by Alaska. In rushes, counterclockwise, flowing in. Here's a high pressure system, the wind's flowing out clockwise. So winds are always moving, and they're always moving because of differences in pressures. And an easy way for us to show the differences in pressure is by drawing these lines called isobars, and we also have lines called isotherms. So right now, why don't you take a practice drawing your own isotherms? This is something we're going to have to do on your regions, on your milestone. And so we're going to practice right now get out this worksheet, please. So the first one asks you to draw the 20 and 30 isotherm. So what we do is we just kind of take our pencil and we have to draw a line, and what we're saying is a 20 isotherm means anything on the line is equal to 20 and anything below the line is less than 20. So I can just start my line here, moving right through. Alright, I'm going to label that 20. It's hard to write numbers with paint. Alright, I need to do a 30 isotherm. So now I need to make sure that I'm starting at the edge. I'm keeping everything above 30 out on top of that line and everything below 30 inside that line. Alright, there we go. I'll write 30 over here. Okay, so on the line is the point of 30, on the line is the point of 20, but in between is 25. Below 20 would be 12 and 15. If we asked you to draw like a 10 isotherm, where would that go? Right, it's got to go below the 12 and the 15. Alright, so I'm going to let you now move on, and you're going to need to do, that was the level 1, the easiest one. You're going to need to do level 2, 3, and 4 on this worksheet. When you've completed this worksheet, you need to ask for the really challenging level 13 isotherm. Alright, hopefully this was helpful. If you have any questions, you can go back and rewatch this, or you can ask for help from one of your group mates or a teacher. Don't forget to go to office hours if you're really stuck. Milestone coming up soon. Make sure to understand these pieces so you can do your milestone very successfully. Thanks a lot.